right, good morning. I have several steps that we're going to take here. Anytime you're solving any equation, before we get into the 2.2 and 2.2 and 2.3 homework, if you'll write down these steps, these will help you solve any equation. Now, a lot of equations, there's several of these steps you won't even have to use. Like in 2.2, most of these steps we aren't even going to use. So I am just going to talk through them first. So steps to solving equations. Remember how much we do not like dealing with fractions. So that's why I'm going to remove the fractions at the very first step. Because once you've removed the fractions from the equation, it's a lot easier to solve. All right. After there's not any fractions, then you're going to look and see if there's any parentheses. If there's some parentheses, we're going to take steps to remove those. All right, my third step is when you're looking at the equation on either side of that equal symbol, if there is like terms on either of those sides, you're going to put them together. Like for instance, if you have two terms that are x's on one side of the equal, you want to put them together. Or if you have like a 3 and a -6 on one side of the equal sign, push those together instead of leaving them as two separate terms. So once you've combined the like terms on each side of the equal symbol, and these will make more sense once we start solving the problems. I just want you to have a playlist to help you go through each problem, okay? If the variable, which is the letter, a lot of times it's an X, if you see it on both sides of the equal sign, because remember the goal of solving the equation is to get the variable by itself. Well, if you see it on both sides of the equal symbol, then you need to cancel one of those out so that it's just on one side. And again, once I talk through these in actual problems, you'll see more what I'm talking about, okay? So, and we're also going to cancel out the smallest one on those variables. And the reason for that is that keeps your variable positive, okay? The next step is to cancel out anything that's added or subtracted on the same side as the variable, okay? And we did some of those in 2.1, so you've already practiced that a little bit. And then the last step is to divide by whatever is hooked onto the variable. And that's where we're going to start today, are problems that just have this last step, okay? So if you need to pause me for a little bit to write those steps, go ahead and do that. And we're going to start working problems like you're going to see in 2.2. Okay, so first, before we do that, I'm going to go over kind of some of the kind of problems that we did in 2.1 just to lead us into this. So remember, when we were doing 2.1, you had problems like x plus 7 equals 15. If you're trying to isolate this x, the only thing you need to do, because for x to be alone, the only thing that needs to go away is that plus 7, right? Well, how do you get rid? Remember, you just do the opposite. If you get rid of a plus 7, you need to subtract 7. Whatever you do to one side, you have to do to the other. So now I'm left with x equals 15 minus 7, which is 8. So those are like the problems that we did in 2.1. Problems starting in 2.2, like number 1, will look something like this. Good morning. So 6x equals 48. So when I'm talking about this 6 is not added or subtracted to that, right? What is that? What does that mean when it's the 6 is hooked on to the x? It's multiply, right? Which means, what's the opposite of multiplication? Division. So that's how, if something is hooked on to this x, that's how you get rid of it, okay? If you look back at the steps that we just wrote down, that's the very last step, okay? The very last step of solving equations is to divide by whatever is hooked on to this x. So let's go ahead and divide by that 6. If I do it to this side, I have to do it to that side. So let's see, these 6's cancel. That's the whole reason I did it. Bring down this x. Equals, over here, 48 divided by 6 gives me 8. Okay? And you'll just do, if to be more comfortable, if you want to do that division in your calculator, go for it. It's what we have it for. Okay? So again, all those 6 steps that we wrote down at the beginning, most of the time you're not going to have to use every single one of those steps. All right, let's look at a problem like number 2. You know what? I'll leave that up there. Put it over here. You have 18m equals 11. All right, so once again, what is hooked on to the x, right? The only thing that needs to go away, or not the x, this is an m. The only thing that needs to go away is the 18. Is the 18 hooked on? Yes. How do you get rid of numbers that are hooked on? Divide by them. So this 18 cancels out that 18. There's your m. Now look at this. If you are not sure about this, because this one divided evenly, right? 48 divided by 6, divided evenly. If you are not sure, in your calculator, do that 11 divided by 18. So just 11 divided by 18. If you're not sure if that's in simplest form, because that's what it's going to have to be, that's when, again, you hit this math. That tells this, you're telling it you want to reduce that fraction to see if it divides. So math, enter, enter. Now look what it told me. It told me 11 over 18. If that fraction would have been able to reduce, it would have done it there. It would have reduced it for you. But since it didn't, that is just simply the answer in its simplest terms, is the 11 over 18. Number 3. 15t equals negative 72. So what is hooked on to that t? The 15. So that's what we're going to divide by, is the 15. So I'll bring down my t, because the 15's canceled. Over here, I need to figure out what is negative 72 divided by 15. So again, I would punch that in this calculator, right? So remember, let me clear it out. Your negative button is down here at the bottom below the 3. So negative 72 divided by 15, and then hit enter. Now look, it gives me negative 4.8. Now here's the thing, your math lab is not going to accept a decimal. It says type an integer or a fraction. It doesn't want that decimal answer. So what is our go-to? Math, enter, enter. That reduces that negative 72 over 15 to its simplest terms. So again, math. So hit math, enter, enter, and that reduces that fraction for you. So you see what it reduces to? It reduces to negative 24 over 5. Okay? So negative 72 over 15 reduced to negative 24 over 5. You know, used to, we just had to say, okay, how does this reduce? We would have to find a number that went into both of them and divided it out of both of those. But now, with this calculator, that math enter, enter, that's what that does for you. All right. Number 4, 18m equals 0. Once again, you're dividing by whatever is hooked on, which in this case is the 18. So the 18s cancel. Bring down your m. Equals, over here you've got 0 over 18. Now here's the thing, 0 over anything is simply 0. Okay, doesn't matter if your 0 is in the top, it doesn't matter what this is. It doesn't matter if it's positive or negative or a decimal or anything. If 0 is your numerator, 0 is the answer. All right, number 5, this is where we have another step. 4m plus 8m equals 96. Okay, so once you start getting into the more steps of an equation, that's when you're going to want to refer to that list. Okay, and so you would look to remove any fractions, don't have that, no parentheses. Now, the third step says combine like terms on each side of the equal sign. That is something that I have here, right? These are like terms because they're both m's, right? If they're both m's, there is not a reason in the world to write a 4m and an 8m when you could just as simply write 12m, right? There's no reason to write them separately when this right here on the same side of the equal sign, here's my equal sign, since they're on the same side, not a reason in the world you can't write that as 12m, which makes it more simplified because then it's just one term instead of two separate terms. Bring down this 96. So now we're like the problems in the rest of this section. All I'm left with to get that m by itself is what is hooked on, which means that's what I'm going to divide by. So m equals, and then I'll just go to my calculator and do 96 divided by 12, and it gives me a whole number. It just tells me that is 8. All right, x plus x minus 3x equals 11. All right, so just like the previous kind of problem, I've got way too many x's over here. No sense in writing all those x's when you can just push them all together. So let's see, if there's not a number hooked onto an x, how much is this one right here? 1. All right, that's 1. and that's 1. Oops, can't do that very good. So I need to know that since I'm going to be combining them. So this is 1 and 1, so now I have 2. But I also have this minus 3. So if I put all those together, I have 2 minus 3, which actually gives me negative 1 x's all together. Again, you can punch that all in your calculator. If you're not sure, okay, you just simply do, let's see, what do I need to know? I need to know what 1 plus 1 minus 3 is. Just type that in. 1 plus 1 minus 3. So 1 plus 1 minus 3, hit enter. That tells you that it's negative 1. So if you aren't sure, because it's going positives and negatives all over the place, just punch that in your calculator. So I have negative 1x. By combining all these, I still have equals 11. So x is still not by itself though, right? It still has something hooked onto it. What is that number that's hooked onto it? Negative 1. Now, when I'm dividing, I don't change the sign. I divide by exactly what is hooked on. So here I am dividing by negative 1. I do it to one side, I got to do it to the other. So the negative 1's cancel. I bring down that x equals 11 divided by negative 1. What happens when you divide something by negative 1? Its sign does what? Changes, right? If you divide by a negative, it's going to change that sign. So it's just going to be negative 11. Okay? All right, so that is actually the end of that section. So we're going to go ahead and do some 2.3 work also. Now I know it looks on the week 2 folder, it says we're just covering 2.2 and 2.3, but we might be able to get a little bit further. We'll just see how it goes. We may on Thursday just do some more solve an equation work, okay? But we're going to try to get through, if we can get into some 2.4 stuff on Thursday, that's great. If not, no big deal. Okay, this 2.3 has equations that have several more steps. Okay.
You need to say this was 2.3.
We just did 2.2. We're about to get into 2.3. Yes.
What's up, peeps?
Good morning. So you already did a lot of 2.2 and 2.3, huh?
Yes, ma'am. I'm trying to get as far ahead as
Go ahead.
I can.
Go for it.
I was saying that the other night. I said, can I just go on? I said,
Yeah. Yeah, you can't mess up. You can't mess it up because even if you get problems wrong, you can go back in and click similar question and get them right. You cannot hurt it.
So if you get a problem wrong, does it continue to give you that same problem and it says similar problem over and over?
Usually it'll give you 3 chances to work a problem, the same problem. If you get it wrong, and then on the last chance, it'll say final check. Instead of check answer, it'll say final check. So if you get it wrong that time, then it's going to give you a red X on that particular problem, but then it'll say similar question. You can work that, click on similar question. It'll give you a new question. It'll just change up the numbers a little bit though. And then you can still get that problem right. Yeah.
Well, I did that actually for similar question, and it did it repeatedly, like 3 or 4 times.
Oh, I need to see where you are. I need to make sure you're in the right spot.
Okay.
Yes, I want to see what you're doing because I want to make sure you're in the right spot.
Sorry.
That's what I was trying to say. Like when I'm on the screen, isn't it like the work for today, the work for this next week, or doesn't they say that? Is that the part that I'm supposed to be in?
You do the week 1 folder. That's where, like, I'm recording this video. I'm going to put this video in the week 2 folder now.
So am I having I just go off of what work is due today on that little screen?
The work that you turn in is on My Math Lab student links. Every single item that you are going to turn in this whole semester is in My Math Lab student links. So if I need to open some things up because y'all were, if anybody was confused last week about where to turn stuff in, shoot me an email or just tell me, and I'll go back in and open it back up. That's not, it's just clicking a button. Okay? So if that needs to happen, let me know. But yes, and we'll make sure that you can get there before you leave today. But My Math Lab student links is where 100% of the items that you are going to turn in for a grade, that's where they're found. Okay? All right. 2.3. All right. Couple of new things that you're going to run into. I do have, first of all, going through that list, no fractions, no parentheses. I do have like terms, but they're not on the same side of the equal sign. So that is the next step, that's step 4, where you put the variable only on one side. So do you see how I have x? Your whole goal is to isolate the variable, right? To get the x by itself. Well, if I have x's on both sides, I can't do that yet. So now I've got to take a step that says cancel one of those. And I'm going to cancel the smaller one because that will keep my x's positive. There's not a steadfast rule that says which one you have to cancel. You can cancel either the 7x or the 5x. There's not a rule that says you have to cancel one or the other. But I just prefer to cancel a smaller one because that'll keep my x's positive. So which one's smaller, 7x or 5x? 5 is smaller than 7, right? So I'm going to cancel that. I'm going to get rid of this positive 5x. I'm just going to subtract it off. Right? That'll get rid of it on that side. If you did it to one side, what else has to occur? Do it to the other. Now, when I do it to the left side, what am I going to put the minus 5x under? The other x, right? You want to subtract it from its like term. So if I subtract 5x here, I'm also going to subtract 5x here. So here's my equal sign. Just bring it straight down. Because look, what are you left with over here? If you had 5x, but you took it away, you're left with a big fat nothing. 0. Big fat nothing. 0 is not, there's nothing left over there. I canceled the whole side, which is fine. 0 is just another number. So let's see what's left over here. How much x's do I have if I took 5 away? 2 x's. This I haven't done anything with, so I'm just going to drop down to minus 6. So now I have 2x minus 6 equals 0. So let's see, after step 4, where it says put the variable on one side, now step 5 says cancel anything that is added or subtracted on the side of the variable. Because remember, my goal, now that I just have x's on this side, what does x want to be? X wants to be alone. Which means whatever is hooked on is 100% of the time the very last thing you're going to get rid of. So you're not getting rid of that 2 until the very end. Okay? You want to get rid of anything that is added or subtracted on the side of the x. So I need to get rid of the minus 6. How do you knock out a minus 6? Plus 6. That's right. You do it to one side, do it to the other. So now let's see, I've got 2x left here. Drop down my equal. What's going to happen here? What's 0 plus 6? 6. 1. Now, the only thing that is left is what is hooked on to the x. How do you get rid of what's hooked on to the x? Divide. Divide by 2. Divide by 2. So now, x equals 6 divided by 2, which just gives you 3. All right, so you just put in 3 as your answer. Number 2. So we've got 9x plus 37 equals 5x minus 11. All right. No fractions, no parentheses. Do I have x's on both sides? Yes.
Oh,
I've got x's on both sides. Cancel out your small one. Who's small? 5. Cancel him out with the minus 5x. If I do the minus 5x here, I have to do it over here. Put it underneath the other x. So I'm doing minus 5x under here, under that 9x. So on the right, it canceled, right? That was the whole point. So all I have left on the right, don't forget the sign, bring down that whole thing. You are left with a negative 11. Let's see what's left on the left side. How much x's do I have? If I had 9, but I had to take away 5, I'm only left with 4. X. Bring down that plus 37. So now I'm to the point where all my x's are together on one side. Now the x wants to be alone. Remove everything on the side of the x. Who goes away first? 37, right? You want to make that plus 37 go away. What is the very last step every single time? Dividing by what's hooked on. Don't even pay attention to that until it's the only thing left. So I'm going to get rid of this plus 37 with a minus 37. So I have 4x left here. Now let's see. I'm not comfortable doing all that in my head. Just take it to your calculator. What do you need to tell your calculator? What are you wanting to do? You're wanting to do negative 11 minus 37. So that's exactly what you tell it. Now remember, your negative button is down here below the 3. So negative 11 minus 37. And then hit enter to get negative 48. Now, what's the last step? What is hooked on? The 4, so you're going to divide. Whatever's hooked on, you divide by it. So the 4's cancel. There's your x.
Here's where I get excited.
Okay.
I'm going to assume that's negative 12.
You'd
Is
be
that
assuming right,
correct?
yeah.
Okay.
Because first of all, think about your sign. If you have a negative and a positive when you're dividing, it doesn't matter who's bigger, it doesn't matter who's smaller, it doesn't matter who's on top, it doesn't matter who's on bottom. If you've got a negative and a positive, your answer is going to be negative, right? Different signs when you're dividing gives you a negative, okay? And again, if you're not sure, punch that in your calculator. Look, if negative 48 was my last answer in my calculator from doing this part, gave me negative 48. So that's my last thing in my calculator. Now all I have to tell my calculator is divided by 4. If I just hit divided by 4 straight from here, it's going to divide whatever my last answer in that calculator was. So if I hit divided by 4, it's going to say, okay, whatever your last answer was, which is negative 48, and then it's going to divide it by 4, and hit enter, negative 12, right?
So if you have a positive and a negative in the division, it's always gonna be negative.
Absolutely, 100%, 100% of the time. Different signs give you a negative answer. Same signs give you a positive answer when you're multiplying and dividing. 100% of the time. Mhm. All right, something new. I don't have any fractions. That's what I'm looking for first, because if they're there, I want to get rid of them. But I do have parentheses on this one. You got to do that first. So I can't put any of that together. I can't put those together because they're not the same kind of term. How do I remove the parentheses? Whatever is hooked on to the parentheses, which is this negative, you're going to distribute it through there. And by distributing, I mean you're going to multiply everything inside the parentheses by what is hooked on to the parentheses. If it's just a negative, what does that stand for? Negative what? Negative 1. Right? That's the same thing as saying negative 1. So I'm multiplying if it meant negative anything else, it would have that number. If it meant negative 4, it would say negative 4. If it's just a negative hanging out there, it means negative 1. So let's see. If I multiply, I got to bring down my equal sign. What happens when you multiply 3x by this negative 1? What does this negative 1 turn that into? Negative 3x. Because if you multiply something by a negative 1, the only thing that happens to that term is its sign changes. Multiplying something by negative 1, doesn't matter what it is, it's going to change its sign. So let's see here. Now, I got to do negative 1 times positive 3. Negative 1 times positive 3 makes it negative 3. Again, multiplying something by a negative 1 just changes its sign. All right, I'm going to drop this other side down just to be even. Okay, parentheses are gone. Moving on to the next step. Put the variable only on one side. Do I have x's on both sides? I do. Now, here's where I, again, like to cancel out my smallest one. Now, be careful here. How much x is this? It's positive 1x. This one's negative 3x, which means this one's smaller, right? How do you cancel out a minus or negative 3x? What's the opposite of taking away 3? Adding 3. You want to cancel it out. So I'm going to need to cancel this out. I need a plus 3x. If I do it over there, I got to do it over here. Put it underneath its like term. So if I did plus 3x there, I got to do plus 3x here. All right. Drop down your equal sign. These x's are all gone, right? The negative 3 and the positive 3 canceled out. What are you left with over there? That negative 3. Let's see what we got on the left side. Remember, if there's nothing showing, how much does this represent? That's 1x. And I added 3 more x's to it. So now I have 4x. Bring down the plus 2. So now I'm at 4x plus 2 equals negative 3. What am I going to do next? I need to get rid of the plus 2, right? You don't ever get rid of what's hooked on until the last step. That's always your last step. So if I get rid of a plus 2 with a minus 2, minus 2. So I still have 4x. So I'm still working. Equals negative 3 minus 2. Punch it in. If you do negative 3 minus 2 in your calculator, you're going to get negative 5. If it's hooked on, divide by it. Divide by it. So the 4 is gone. X is alone like it likes to be. What do I have over here? I've got negative 5 over 4. If I type that in my, try to divide that in my calculator. So negative 5 over 4. And hit enter, look what it tells me, negative 1.25. What do I do to make sure that negative 5/4 is in lowest terms? Math, enter, enter, right? It's gonna be our best friend this semester. So math, enter, enter, and what does it tell me? It says negative 5/4, which means it was already in its lowest terms, right? If it wasn't in lowest terms, it would have reduced it with that math, enter, enter. So this right here is just simply what the answer is. It didn't reduce anymore. All right, so we're just adding more steps to these equations. Negative 3p plus 7 equals 5, this one's tricky, minus parentheses 12p plus 6. I'm going to rewrite this just a little lower because it's in the glare on the video. I'm just going to write it a little lower to get out of that glare. Okay, going through my steps. Do I see any fractions? Nope, still not there yet. Do I see parentheses? Yes. Now, be careful here. That 5 is not bumping up against those parentheses. There's something separating it. What's actually bumping up against the parentheses is just that negative, or like a negative 1. So again, you're just distributing that negative. So I'm going to drop down my equal. I'm just dropping down this 5. If that minus wasn't there, then you would have distributed the 5. It would have been bumping up against the parentheses. But that minus is there. So that's what's touching the parentheses. So that's what you distribute. So since it's at minus, what do I need to think of it as? 1 is what I'm distributing. So negative 1 times 12p gives me negative 12p. Negative 1 times positive 6 gives me negative 6. All right, I'm just going to drop down this other side. Negative 3p plus 7. So after you remove the parentheses, you say, okay, are there any like terms on the same side of the equal sign? Well, here I've got a p and a 7, so those aren't likes. I can't put those together. But look at this other side. Look at that 5 and that negative 6. Those are like terms. Again, there's no reason to write those two terms. If they're on the same side of the equal sign, there's no reason to write those two terms separately when they can just as easily be pushed together. So here, first thing I'm going to do is bring down this equal sign. So let's see, I can either bring down the negative 12p and then put those together, doesn't matter, or you can put those together and then drop down your negative 12p, because this negative 12p doesn't have anybody to go with over here, right? So at some point, I'm just going to I'll just drop it down right now. Be done with it. So just drop down the negative 12p, put these together. I've got 5 minus 6 on the same side. 5 minus 6 is the same exact thing as saying negative 1. So this level and this level say the same thing. It's just that when you put the 5 and the minus 6 together, it just simplifies your problem for you. Again, I'm just dropping down the other side. So when I look at each side, I've cleaned up each side. There's not any like terms over on that side. There's not any like terms over on that side. So now I do have p's on both sides. I want to cancel one of them out. I want to cancel out the smallest one. If you end up not doing that, it is not going to affect your problem. Sometimes when you have two negatives, it may be difficult for you to determine which one's smaller than the other. It doesn't matter which one you cancel out. I'm going to cancel out the negative 12 because it actually is smaller, right? It's more down negative than negative 3 is. And again, I still always relate this to my bank account. Would you rather, you don't want to have either one of them, but would you rather have negative $3 or negative $12? You'd rather have negative 3, right? Because then you're almost even. Negative 12 is farther down. So I'm going to cancel out the negative 12. How do you get rid of that? With a positive 12p, which means I need to do a positive 12p over here. So the negative 12p and the positive 12p cancel. There's my equal sign. The only thing that's left on the right now is that negative 1. Let's see what's left over here. I had negative 3p, but I added 12p to it. Negative 3 plus 12. Again, just punch that in. Negative 3 plus 12 gives you 9p. Drop down your plus 7. So now I'm at 9p plus 7 equals negative 1. I'm going to write this a little lower. It's all getting... So I'm at 9p plus 7 equals negative 1. So now I don't have p's on both sides. I just have the p over here now. Get the p alone. Who goes away first, the 9 or the 7? The 7, right? The hooked on number is always less. So get rid of plus 7 with minus 7. So now I have 9p equals, over here on the right, I've got negative 1 minus 7, punch it in, gives me negative 8. What's the last step? What are you going to divide by? 9. So let's see, the 9s cancel. All you're left with is that p. What do you have over here? Negative 8 over 9. Does that reduce any? No, that's in its simplest form. So just negative 8 9 is your answer. All right, we're going to do 2 more for today, and then we'll get into the lab and look at all that. And if anybody's watching live, I'll leave this open. I'll just stop recording so you don't have to watch that at home if you're rewatching the video. But I'll leave it open to where if you're at home on Thursday and we're during lab time where I'm walking around helping, I will come and check the chat to see if you have a question if you're watching live, okay? All right, let's do 2 more for today, and then we'll do the rest of this section on Thursday. Because number 7 starts getting into fractions. We'll leave that for Thursday. Okay. The right side looks good. The left side looks like a mess. It's a mess. So let's work on cleaning up that left side by following our steps. No fractions. What's after removing fractions? Remove parentheses. How do you remove parentheses? You distribute whatever is bumped up against it. So let's see. I'm going to, again, seems like this is a common thing, distribute that -1 through those parentheses, which means the parentheses will disappear. And since I'm multiplying by -1, all the signs in there are going to change. Positives are going to turn to negatives, and negatives are going to turn to positives because I'm multiplying by -1. So what is this 8x going to turn into? -8x. But what is this -4 going to turn into? +4. Good. Now, this is in the parentheses. I'm just going to drop it down. Just bringing it down to our level. So plus 5x minus 7 equals -3. I still got some cleaning up work to do. Do I have like terms? Let's see. Here's an x. Is there another x on this side of my e? Here's my equal sign right here. Yeah, that one. So I need to put this guy and this guy together, right? There's no reason to write them separately. They're all x's. They're all the same. Put them together. So I have a -8x and a +5x. So what I really have, truly and really have, is -3x. What else can I put together? The 4. Why not just put it with that -7? So on the same side of the equal sign. So if you have 4 and -7, you really just have -3 all together from putting this and this together. The +4 and the -7 just went together to make negative or -3. So look how much simplified this is. What's over on the right still? Still just -3. So now look what you have on the left. It's very cleaned up now. I only have x's on this side. I don't even have any x's. I don't even have to worry about that step. I don't have any x's over here. I only have x's on this side, which means get me alone, right? It wants to be alone. So don't get rid of what's hooked on. You're getting rid of this -3 first with a +3. +3. So all I have left over here now is -3x equals, all I have left over here, what's that? 0, isn't it? You got -3 + 3? Well, that's nothing, it's 0. Now, what is hooked on? -3. If it is hooked on, that is exactly what you divide by. You don't change its sign. You don't try to do anything fancy with it. Whatever is hooked on, it's not going to matter this time because I got a 0 over there. But most of the time this will matter. You don't change the sign or anything. I'm dividing by -3 on both sides. So let's see, my negative 3's cancel. I'm just left with the x equals. Remember, it doesn't matter what the denominator is. If your numerator, if your top is 0, your answer is 0. All right, last one for the day. Number 6, like number 6, 8x minus 3. Times x minus 2 equals 5x plus 3. Okay? No fractions. Moving on to parentheses. I do have parentheses. What is hooked on? Negative 3 is what is hooked on. That's what you're going to distribute, which means multiply everything in the parentheses times negative 3. So I'll just drop down this 8x. It's just going to come down. So let's see. Negative 3 times x is just negative 3x. Then what do I have? Negative 3 times negative 2. What do you get when you multiply two negatives together? A positive, right? If you're multiplying two negatives, again, if multiplying and dividing and adding and subtracting with positives and negatives is not your thing, punch it in. Negative 3 times negative 2 is positive 6.
That's a quick question.
Go ahead.
On the last one, when we did that, it made everything inside the parentheses opposite. What changed?
It didn't. If I'm multiplying a net by a negative, these signs are going to change. That positive changed to a negative. That negative changed to a positive. My signs change. The only thing different is that I'm multiplying by not just, this one was multiplying by negative 1. The only thing different here is this is multiplying by negative 3. My signs still change because I multiplied by a negative.
The number outside the parentheses does not change. The number inside.
The signs inside the parentheses are going to change. If you're distributing a negative, the signs inside the parentheses are going to change. Drop it down. All right, parentheses are gone. Look at either side of the equal sign. Do you see anything you can clean up by putting terms together? Look at your left. Who can you put together over here? Those x's. No reason to write them separately when you can push them together. 8x minus 3x is the same exact thing as saying 5x. Bring down my plus 6. Equals 5x plus 3. Ooh, I didn't think we were going to run into this. Do I have x's on both sides? What happens? I can't tell which one is smaller because they're what? They're the same. So what happens if I decide to cancel out this one by subtracting the 5x? I have to do it over here. So it canceled it here, but what else did it do? It canceled it there also. My x's are completely gone. All I have left is this right here that says 6 equals 3. Is that a true statement? Does 6 equal 3? No. That just means if your x's cancel, but you don't have a true statement here, there's just no solution. There's not a number that you could put in for X that would make that right. So this, again, this one is actually multiple choice. And it'll say that bottom one, the solution set is, it's got that little circle symbol with a line through it. That just means there's no solution. Nothing works. Nothing can plug in for X and make that work. Okay? Okay, so we're going to start with number 7 on Thursday. If y'all wanted to go ahead and work, and I want to see your other stuff. That's fine. I'm going to stop the recording, I think.